Hello, everyone. Welcome to today's presentation. I'm excited to talk about dependency injection, or DI for short. The title of our session is Introduction to Dependency Injection. Over the next few minutes, we'll explore what DI is, how it helps in software design, especially in Android development, and how frameworks like Hilt make it all easier. So, let's dive in and see how DI can improve our coding practices and streamline our projects. So, why do we use dependency injection? Well, one of the main reasons is the separation of concerns. When we design our classes, we don't want them to be responsible for managing their own dependencies. Instead, dependency injection helps keep our business logic classes focused solely on their core responsibilities, making the code cleaner and more maintainable. Another key benefit is testability. By using dependency injection, we can easily swap out real implementations with mocks or fakes during testing. This means we can write more reliable tests without relying on actual external dependencies, which can be slow or unpredictable. Reusability is also a big advantage. When dependencies are injected, shared components can be reused across multiple classes without duplication. This promotes code reuse and reduces the chances of bugs creeping in from inconsistent implementations. Finally, lifecycle awareness is crucial, especially in Android development. Tools like Hilt integrate seamlessly with Android lifecycles, such as activity, fragment, or view model, handling scopes automatically. This means dependencies are created and destroyed at the right times, helping us manage resources efficiently and avoid memory leaks. Overall, dependency injection aligns perfectly with our goal of building modular, testable, and efficient applications. All right, let's dive into the core DI concepts. First up, we have the module. Think of it as a provider that supplies dependencies through annotated methods. It's like a recipe that tells Dagger how to create or obtain the objects we need. Next, there's the component. This acts as a container, orchestrating how dependencies are assembled and supplied to different parts of our app. It's essentially the bridge between the modules and where the dependencies are injected. Moving on, scope is a crucial concept because it defines how long our provided instances live. For example, a singleton scope means the same instance is reused throughout the app, while activity-retained scope keeps it alive across configuration changes. This helps us manage resources efficiently. Finally, the injection site is where our dependencies are actually requested. Whether it's in the constructor, a field, or a method, this is the point where dependencies are injected into our classes. Understanding these concepts helps us design a clean, maintainable dependency injection setup that supports the overall structure and lifecycle of our application. All right, let's talk about adding Hilt dependencies to your project. First, in your module-level build, Gradle file, you'll notice that we specify the dependencies block. Here, you'll include the core Hilt library with implementation, com.google.dagger, Hilt Android, 244. This is essential because it gives you the core features of Hilt for dependency injection. Next, you'll see the capped line for the Hilt compiler, which is com.google.dagger, Hilt Android compiler, 244. This compiler processes your annotations and generates the necessary code behind the scenes. It's also important to highlight the integration with Jetpack components, so we include Android's, Hilt, Hilt Life's, view model, 1.0, 0 alpha 05 for view model support, along with its compiler. This setup really streamlines injecting dependencies into your view models and other lifecycle-aware components. Now, moving on to your application class, you need to annotate it with that Hilt Android app. This annotation is crucial because it triggers Hilt's code generation, setting up the dependency container for your entire app. And then, you simply declare your class as extending application, like class myApplication, application. This setup is the foundation that allows Hilt to manage dependencies across your entire app seamlessly. Connecting this to the overall theme, these setup steps are the essential first moves to integrate Hilt into your project, making your dependency injection more straightforward and maintainable. Let's take a closer look at what a module is in this context. A module class, like network module here, supplies dependencies that our app needs. Think of it as a provider of essential building blocks. When we annotate it with module, we're essentially telling Hilt that this class will contain methods to create and supply objects. Next, we see it install in singleton component, class. This part is crucial because it binds our module to a specific Hilt component. In this case, the singleton component, which means that the dependencies we provide here will have a singleton scope, lasting for the lifetime of the application. It helps manage the lifecycle and scope of these dependencies efficiently. Within this module, we have provider methods marked with @provides. These methods are responsible for constructing the actual objects, like OK, HTTP client, and retrofit in this example. The @singleton annotation on these methods indicates that Hilt will create only one instance of each, shared across the app. This ensures consistency and saves resources. For instance, the provide OK HTTP client method builds an OK HTTP client with a call timeout of 30 seconds. Then, the provide retrofit method constructs a retrofit object, using the OK HTTP client we just created and setting the base URL for API calls. Overall, this setup is a clean and efficient way to manage dependencies, ensuring that every part of the app gets the right instances, properly scoped and configured. It's a key part of making our app modular, testable, and maintainable. All right, let's talk about injecting into activities and fragments. First, it's essential to annotate your Android classes with @Android entry point. This tells Dagger Hilt that this class is a potential entry point for dependency injection. For example, in our main activity, we add @Android entry point right above the class declaration. Next, within these classes, you can request dependencies by using @inject on fields or constructors. In the example, we have a latinate var retrofit, which is marked with @inject. This way, Hilt will handle providing the retrofit instance when the activity is created. When the onCreate method runs, the retrofit variable is already initialized and ready to use, simplifying your setup process. The key takeaway here is that by annotating your classes properly and using @inject on your dependencies, you streamline dependency management in activities and fragments, keeping your code clean and modular. This approach fits into the larger theme of making dependency injection seamless across your app components. Let's talk about view model injection with Hilt. On this slide, you can see the annotation @Hilt view model. This is a key part of how Hilt helps us manage dependencies for view models. When you declare your main view model class and annotate it with @Hilt view model, Hilt knows to generate the necessary code to supply its dependencies, like the user repository here, which is injected via constructor with @inject. This setup makes your view model ready to use, with all its dependencies provided automatically. Now, in your activity or fragment, you simply declare your view model with private val view model, main view model by view models. This delegates the creation to the Android X view model system, but thanks to Hilt, it injects the dependencies seamlessly. The most important concept here is that @Hilt view model enables Hilt to supply your view model dependencies automatically, making your code cleaner and more maintainable. It connects directly to our overall goal of simplifying dependency management in Android development, ensuring that your view models are always properly wired up without manual setup. All right, let's dive into qualifiers and custom scopes. First, qualifiers. These are really handy when you have multiple bindings of the same type. They help distinguish between them, making sure the right one gets injected where needed. For example, in our code, you see the @auth retrofit annotation. That acts as a qualifier, ensuring that when we request a retrofit instance, we get the one configured for authentication. Now, moving on to custom scopes. These are useful for managing the lifecycle of objects, especially when you want shorter-lived instances. Think of scopes like @activity scoped. They ensure that an object lives just as long as an activity, which is perfect for things that shouldn't persist beyond that. Using custom scopes helps us optimize resource management and makes our dependency injection more precise. Connecting this to our overall theme, Understanding qualifiers and scopes really empowers us to write cleaner, more efficient code. It allows us to control how and when objects are created and used, which is essential in building robust Android apps. All right, let's talk about testing with Hilt. So, when you're writing tests for your Android app, you want to make sure you're properly isolating your components. That's where Hilt Android Test comes in. You annotate your test classes with this to enable Hilt dependency injection in your tests. Inside your test class, you'll see we declare a Hilt Android rule, which is essential because it manages the injection process for your tests. Think of it as the conductor making sure everything's in harmony. Next, we have the @inject annotation on a fake repository, like fake user repository. This allows us to inject a mock or fake version of a dependency, giving us control over its behavior during testing. It's a key part of creating deterministic, reliable tests. Before each test runs, we call Hilt_inject in a setup method marked with @before. This ensures all dependencies are properly injected before the test executes. Then, in our test function, say test_user_fetch, we use the fake repository to simulate fetching user data. This way, we avoid relying on real network calls or databases, which makes our tests faster and more predictable. Now, onto the second key point, replacing real modules with test-specific ones. You do this using @test install in. This annotation allows you to override modules for testing purposes, so you can control what dependencies are injected during your tests. By controlling your modules and dependencies, you create a controlled environment for your tests, which is crucial for reliable and repeatable testing outcomes. Connecting this all to the overall theme, using Hilt for testing simplifies the setup and makes your tests more maintainable. You can easily swap out real implementations with fakes or mocks, ensuring your tests focus on the logic you want to verify. All right, let's dive into some best practices and tips for working with Hilt. First up, constructor injection. This is generally preferred over field injection because it makes dependencies more explicit and easier to test. When you use constructor injection, your classes clearly state what they need, which improves maintainability. Next, it's important to limit the scope of your modules. You want to avoid making modules too broad or turning them into singletons that are used everywhere. Keeping scope tight ensures better control and reduces the risk of unintended side effects. When it comes to injecting into third-party classes, use the @entry point annotation. This allows you to access dependencies without modifying the third-party code, which is super handy and keeps things clean. Another key tip is to keep your Hilt modules small. Each module should serve a specific purpose, making your codebase easier to understand and manage. Small, focused modules are much more maintainable than large, monolithic ones. Lastly, avoid manual dependency lookups. Rely on Hilt to manage your object graph. Manual lookups can lead to errors and make your dependency management more complex than it needs to be. Let Hilt handle the heavy lifting so your code stays clean and predictable. These practices help ensure your dependency injection setup is robust, clean, and scalable, fitting into the overall goal of writing reliable, testable Android code.